Yep, thanks for the introduction. So I'm here today from Quantsite. We're talking about I guess, a service that we're developing called Conda-Store, and we're using it to how can we manage a collection of packages as an environment as a whole, and some of the problems that we've ran into when we've been doing consulting. And I'm hoping to show how um, that after you've packaged a bunch of software, it's also important to think about how you're going to distribute the environments that contain all the packages themselves and manage that. So just really quickly, a little bit about myself. I'm a software developer at Quantsite, like I said. I'm really passionate about numerical computing and reproducibility. And I've done a lot of work around the PyData ecosystem with Jupyter Hub Dask and have really gotten into NixOS and contributing to those packages there, which I think has really, I'd say it's kind of changed my perspective on how I think some things in Conda, um, and specifically how the environments are produced, could be changed. And yeah, so I'm going to present on that. Really quick about Quantsite. The way that I think about Quantsite is we're trying to make open source sustainable, and there's a bunch of different methods that we go through to sustain a lot of the PyData ecosystem, but primarily that's done through consulting, and there's a bunch of other stuff. So if you're interested, we're hiring for a lot of different positions, and yeah. So I know everybody here knows a lot about packages and package managers, but I wanted to say, why are we choosing Conda um, for managing environments specifically for this tool? And it has a lot to do with the clientele that we work with. They're often dealing with very like scientific packages, data science, all the machine learning frameworks, and there's a lot of important bits in there. So one of them that I think kind of differentiates Conda is the Windows, Linux, and Mac support. And when we consider all these bullet points together, it really um, it helps guide why we chose this tool. So the other thing is concept of isolated environments. So if you're working with a lot of the like distribution package managers like apt or yum, those ones you kind of have like a monolithic environment for all users. And then I'd also say the having the fact that we have PyPI, why not use pip for managing packages? And it has a lot to do with the programming language agnostic packaging, because when we have C and C++ compiled libraries, or maybe we need to include some R packages, we really need to think a lot bigger than just Python for these things. And then the final thing that we really see comes to bite people at times is how if you're using pip wheels or wheels with PyPI, is that the compiled libraries will be packaged inside of the wheels, and then you might be dependent on a certain version of OpenBLOS for NumPy. And then when you use a different piece of software, they might have to use a completely different version of OpenBLOS, and you have issues with the sort of like consistency between the compiled libraries that are being used. So now that we've talked about, why we chose Conda, what's really the need for Conda-Store? So this really originated from some of the consulting work that we've been doing, where we started seeing this friction between users, IT, and making environments reproducible. So just give one quick example is that users were often frustrated with IT not being able to add packages fast enough. If you want to use NumPy, you want to use it today, and you don't really understand why IT can't just add it immediately. But then if you look on the other side of the equation, you can see that well, IT has to make sure that it fits their licensing requirements. They might have to vet the package for any security vulnerabilities. Then finally, maybe they need to build a Docker image of your given environment. And then finally, they come off to serving it to you. So maybe you can see there that, I mean, this process can take a few weeks, maybe even a month, depending on the process. So there's really, both sides are right and in being frustrated with the process. And then there's also a bunch of reproducibility things where if users are creating ad hoc Conda environments, what's keeping track of those environments that they were using for JupyterLab development. And if they ever want to run those environments later down the road, how do we balance all that? So because of all of this, we developed Conda-Store, which is a tool for managing it's for management, the builds, and serving of an environments. So what do I mean by managing? The first thing is that it provides just a nice web UI for managing these Conda environments. It also has a full REST API behind all of this. And then finally, it actually watches your file system for any environments that may have changed, and it will auto rebuild them. And then we're also working um, on the Gator project that QuantStack originally developed, and we're trying to integrate Conda-Store and have a JupyterLab UI for managing environments. I might be able to show that really quickly in one of the demos. Then finally, it also builds environments. So some of these environments can be rather large. Maybe they have big constraints on the amount of memory. Whenever you're doing a package solve with Conda, it could consume several gigabytes of memory, and having a place that's dedicated to doing the builds can make that a lot easier. We also designed this in such a way that it can theoretically build in environments concurrently at the same time. And then finally, the really big part for me is that it serves these environments to users in whichever way they need. So it can serve it via the file system, so you can just do like a standard conda activate on your file system. It can serve lock files, so you could just do a conda install and get like an exact reproducible environment there. It also gives conda packs, so you could just download a tarball, unpack it, rewrite some of the paths using conda pack, and then you have an environment ready to go there. And then finally, it also behaves as a full Docker registry. If there's any Nix people around in this talk, I was really motivated by Nixery, which can kind of build on-the-fly Docker environments, and Conda-Store can do exactly that with Conda as well. And then finally, all of this stuff is wrapped by role-based access. So we can have, if your company might have a set of environments that are, the data science environment that nobody should touch, you can have read-only environments and maybe a separate namespace for users so they can modify their own environments. On top of all that, we have vetting of all these packages. You can have like an arbitrary Python function to check that the environment meets all of the IT constraints. And the JupyterLab UI, which I'll show in the demo in just a second. So all of this stuff, I'm going to just show really quick via like a Conda-Store demo. You can easily try this yourself if you just clone this repo, go to the Docker example, and then just Docker compose up. So now I'll just give a really quick demo of it here. So here I just wanted to demonstrate that we have some separate namespaces. So we have a production namespace and then just a default namespace here. We have a data science environment and just several environments we created here. On top of that, we have a pinned environment.yaml that's produced for the environment, a lock file. So if we just click on the lock file, it gives the exact package, including the, I think this is like the MD5 hash of the package. It also gives a conda pack archive. This is something you can easily extract and then, like I said, get the environment. And then finally, this behaves as a Docker registry. So if you click on this, it will copy a Docker, the Docker URL to get the actual environment. So what are some of the things that I think one thing's here, so we see that we have a completed build. We also have the environment here. You can easily edit it and add a new environment, so a new package. So here, let's just add NumPy. And if we go back to this data science environment, importantly, we can see that a new build was queued. So one of the concepts that I wanted to bring to Conda is the concept of rollbacks. So if we have multiple completed builds, we might find that our environment might have broken because one of the package versions was increased, and completely broke our workflow that we had. So you can actually roll back to set this as the default environment. So we'll see right now it's building, but pretty soon when it's completed, we can show how we might be able to switch between the two. All environments are built completely isolated from one another, so we can get a unique build for each version. You get information about when it was run. Conda-Store also has deep knowledge of the packages underlying the actual environment, so we can do interesting things for querying there in the REST API. And then finally, we have the artifacts that are produced. It's not entirely clear here, but there's actually a unique key associated with every single build. So if you did want to run an environment 5 years from now, we have a dedicated key that you can always access that exact same environment. Now, you'll probably run into the issue where maybe there might be security vulnerabilities that have been found since this environment was built, but you at least have a way to sort of freeze a given environment and reuse it for many years to come. You also get build logs on a given environment. So here's just some output from Mamba running for the build. So here, I was showing default data science. We can see that this one finished building, and we can also see that build 5 is now the default, and you can just click on this, and we actually switch the default environment. So we can see how users can easily modify that. You can delete things. All of this stuff is backed behind RBAC, as I mentioned before. There's also namespaces that you can produce. So this is a nice way to protect certain environments from making certain environments only read-only and other ones maybe specifically for a given user. Okay, so going back, I think that's about it for the demo that I wanted to show there. Really quickly, just wanted to show what the architecture kind of looks like for the builds. So we sort of have like an environment, a pointer to a given build. Whenever we talk about an environment, the default one is whatever it points to here, but we can have multiple successful builds for a given environment. There's just one that's the current active default. And this sort of allows us to account for the fact that in Conda, it's not, I wouldn't call it truly reproducible, but we can do our best to keep track of what the environment.yaml file is that we use, and also the time at which the build was done. So I kind of hit on this a little bit before, but to me, this is the key reason why we really need Conda-Store, and that's that whenever you're working in large enterprise environments, you can wait quite a long time to get new packages added to your environment, just due to the time that it takes for IT to go through their process to add the packages, and really both sides have really good reasons for what they're doing. So I mentioned before, really rich RBAC controls around all of this stuff. Conda-Store is easily pluggable to enforce certain constraints. Let's say that you can't install MIT licensed packages. That could be something that could easily be added to Conda-Store. You can say only certain Conda channels are allowed as well. And then additionally, we can have dedicated namespaces that sort of protect users' environments from company-wide managed environments. This is the issue. This is something that I didn't really touch on a little while ago, but one of the other issues that we see quite often is that as an end user, we'll be developing a JupyterLab notebook. And as soon as that notebook is good enough, you tell IT, I'd like to run this once a week for the next 5-10 years. And you're kind of offloading it on IT and making it their responsibility to run that notebook. And the critical piece there is how can we preserve the environment and make sure that we're always using the same one over time. So Conda-Store can really help that because every build is uniquely addressable and easily accessed in many different ways. So it might happen that your environment is Kubernetes containerized, but your actual workflow engine might still be using an HPC environment. So in that case, maybe you might need Conda pack on that side, but then you might need containerization for the Kubernetes bits. And Conda-Store allows you to bridge that gap of different environments. Also, all builds are archived in S3. And then I also wanted to point that we never update a Conda environment. We always create a new one every single time. And that's to kind of nicely isolate every single one and have more deterministic builds, if you might say. So finally, what does the roadmap look for Conda-Store? One thing with talking with the CondaForge developers is that it would be really nice if we had a way for users to do remote Conda solves. And Conda-Store has, I'd say, about 75% of those capabilities already. So we've really been considering exposing a public API for doing something like that. Now, Conda-Store is completely open source. You can run it on your own infrastructure, but we were talking about making this a public resource as well, and then having this API that I talked about there. Additionally, we're building this JupyterLab UI that I mentioned for managing packages. We also want to integrate with Jupyter Enterprise Gateway to be able to take advantage of remote IPython kernels. And I think Conda-Store has a really nice way that it can allow heavily customized kernels to easily spin up. We've also met with some people in academia, and one thing that's been important to them is being able to have singularity containers. And since we're already building multiple output formats, I thought that singularity would be a great fit. We've also been talking about building VM ISOs. So if you're running on, say, AWS, you can have an AMI that you could easily run with that given environment. And this is certainly stuff that Conda-Store could do, and we're considering to add. And then finally, we're integrating into QHub, which is I would say like an auto-scalable data science environment for groups that don't really have DevOps experience. Assume that they don't really know what the cloud is and they don't know how to use Kubernetes. And we're trying to add that into there for a nice Jupyter Hub data science environment. So with that, I have the docs written, included there, and then also the GitHub page for the actual project. So with that, are there any questions?
Hi, Chris. Thank you very much for your presentation. We do have questions. So
Awesome.
Our first question is, do you construct the lock file from the install conda-env or create it from the package plan a la conda lock?
I actually create it. I actually create it with knowing the packages that are in the environment themselves. I did consider using Conda-Lock, but it seemed easy enough. If I understood every single package in the environment, you can create the lock file from the database itself, where the environment is stored.
Cool. Our next question. Does Conda-Store refetch any packages or does it maintain its own local cache? If it refetches, how do you handle packages that have a new Conda build but same version? The lock file is pinned against the specific package build, and in my experience, many popular channels only maintain the current build of a given version.
Yeah. Okay. So that that's a lot of questions there, but I think the first thing is that Conda-Store will download the package JSON for the given channels that you're using, the repo data.json. And it does that every single time it attempts to build an environment just to make sure it has the latest version there, which is a little bit wasteful there. Also, I guess I would say the Conda builds are completely isolated. And I do expect that if you do another build at a different point in time, you will get a different Conda solve. And kind of the point here is that if you can save every single build over time, you can easily roll back to previous ones. So I hope that I answered that question, but I'm definitely happy to talk with you later on the Matrix channel.
Cool. These were the two questions that we had. So people, if you have a question and want to post on the Element channel, that's your chance. But you will be around on the Element channel also later, so if people can there is a clarification on the last question that it was referring to the build number. Sorry for not clarifying. There is another one here. For the pinned YAMLs, do you guarantee reinstallability?
Do I guarantee yeah, so I guess I haven't worked too heavily on that part. I've really tried that anytime I build a given Conda environment, we then try to save that exact environment in as many ways as possible. I think if you're going for exactly identical, you'll have better luck with the Conda pack and the Docker container version, just because one thing that the lockfile definitely can't handle is having pip requirements inside of there.
Cool. So I think that's it for questions. Thank you very much again.